I'll have to figure out how to download the VOD from Twitch later. Anyway, now that I'm recording, some programming stuff. I want to present lists, maps, and enums or enums. There's a million ways to pronounce it. I think basically all of them are wrong because someone will complain about it. I wouldn't worry about it much. Lists. Um, well, actually, I'll show the visual representation of it. Lists are end up kind of being like post office boxes or like lockers. Everything gets a number, and you can put things in those boxes. It's really what it is. It ends up being kind of a representation of your computer's memory, just kind of super ultra abstracted. Because in a way, your system's RAM is like this, except the object is always bytes. Like, a memory address is just an index, and and if the object is always bytes, then you're just directly accessing memory. You all don't have to deal with that in Java, but in C++ you kind of do. But, you know, the reason why lists are so popular of a data structure for most things is they're kind of just based on how the computer works in general with how things are stored in memory. Um, so there are many kinds of lists. Uh, we're going to use the classic array list, which is really, really what I was just talking about. In Java, I'm not sure how the underlying like methods work for an array list object, but in C++, like it ends up basically being like this, where like these are just offsets to memory addresses from some base. Ah. So if you want to declare an array list in Java, you do array list, then you have these triangle brackets or pointy brackets, and you have some type in there. Not literally some type. It could be like integer, double. If you were nuts, you could, say we had like multiple like well actually, here's a good example. We have multiple subsystems on the robot. So we have multiple objects that uh you are based on the subsystem class. You can have an array list of subsystem and just have a list of every subsystem on the robot. I'll actually pause there and see if anyone has any questions to this point. Nothing? No one? No questions? Or maybe the Twitch delay is just bigger than I think it is. Oh, either way. So that's how you declare it. To actually create it, you do new array list, that same type, and then you do the brackets or the parentheses semicolon. Now, this example is you're doing both on one line where you're just, saying, I want an array list of doubles. So that's an array list of decimal numbers. List of decimals equals a new array list. I'll explain why we can get away with no triangle brackets there, parentheses, semicolon. This will declare a new array list of double named list of decimals that will be now equal to a brand new empty array list of double type because um, Java can infer that typing when it's all on one line like this. Demonstrate list in Java. We'll get there. I have this example here, and I can grab it really. I could probably do that really quick. So, for example, so if you want, so you have this new list. If you want to put something in the list, you do the name of the array dot add, and then whatever object you want to put in that list, it has to match the type that you set up here. So, some decimal variable, we're assuming that that's a double. If you want to get things out of the list, remember how I was explaining how they have like a PO box number or like a locker number? You put that in the parentheses and that will get you back, that object. So if you have so here we create the new list. This is a visual representation of the object that you have just created. It's completely empty. Technically, the indexes wouldn't even all exist, but just, effectively they're null. Like the blank objects are null. Null is just a way of, in Java, representing nothing. Like, null is the concept of nothing. Not zero, nothing. Because in programming, zero is something. Null is like that episode's a, that episode of SpongeBob where Squidward ends up in the future with like emptiness around him. So, you want to put things into that array. So you do like some team numbers dot add, and notice this is an integer list. You add 16, you add 33, you add 47. So those go into the array in order. Order is guaranteed with an array list. So then, if you do that and you do some team numbers dot get 1. Oh, and notice how the indexing starts at 0 because computers. Like I said, 0 is something. In this case, some team numbers dot get 0 would actually return you 16. In this case, some team number dot get 1 will get you back 33. And 2 would be 47. So no, I don't want browser help. Yes, and chat window. I even have VS Code open. I don't. So, actually, messing with a different example that I will mess with. So I'm going to put some code here in teleop periodic that is just that. Actually, I'm going to pull that up on my other screen so I can read what I wrote. If I do array list integer from team numbers equals new list. I'm actually just copy these. And I'm going to some team numbers that get 1. So this will spam a bunch of ones. It's the fastest way I had to get a running Java project at the moment. Oh yeah. when you want to use an array list, you have to import it. I just did control and then the period key. That brings up this, hit enter, imported. This should absolutely spam. Platform windows and what? Back in. Has to compile because thing. Both these. This is an incredibly overkill amount of what? No. By DS. Oh, right. Look, it prints 33 a bunch, as I said it would in the example. Then if we disable a robot, and so I could do some team numbers dot add 1806, and we can get 0, 1, 2. That would be the third object in the list. Ooh. Oh. Oops. And then you can see order is completely guaranteed. So, what else might you use an array for, or an array list, other than like just storing things like a database? Say you want to do something like make this a double. Then you wouldn't really do that for the. Well, actually, wait, hold on. Yeah, our distribution panel b equals new panel b dot get. What you could do is you rename this to channel currents. Oh, channel current list. That's a great suggestion. Thanks, Visual Studio. Current list. Then what you do, actually, I don't want to get the channel current list. That is not what I want to do. You do like for int I equals 0, I is less than 16, I plus plus. Take a running total, so double running total. I guess int number of channels equals 16. I want to use that later. Here. So the power distribution panel has 16 different channels. You can actually monitor the current on each one. So what you could do is you get the current on every channel and add it to this running total. Wait, hold on. This example is kind of breaking down here because EP is not actually working how I thought it would. Current list. Oh, so channel current list dot put or add. Put is what you do in C++. Dot add pp dot get current I. That will give you a list of all the currents, and then in theory you could and then once you have a list of all the currents saved off, which I maybe wouldn't do that way, you could do like, you know, mean channel current, median channel current. Mode would never ever be useful. But the idea is that you can do operations to things in a loop. Like you could take the like channel currents and do some calculation based on the channel currents, like figure out the percentage power the whole robot gets. Like it's just a good way to store things. Anyway, moving on. Maps. Used a lot less common on in robot code, but they're still a very common data structure. Is so kind of like how the array list is like a PO box where everything already has an assigned number. You can assign what's known as a key, whereas so you can like name the boxes and they go in there. There's some performance implications of what it's using that key for that we probably won't get into. It's way above most of you all's level at this point. But the main thing you need to know is that it's a way where you can map, well, in Java, you can map pretty much any object type to any object type. Like you can have OPR by team number, for example. And kind of, you know, like how the list works with the add. There's this put function, and it's put and then key comma value. Like, you know, team number OPR. Team number dot get returns 88.53, assuming that that's actually our OPR. Our OPR is 88.53 at Cowtown. We're doing really well. It's kind of like the example we ran through with arrays. You know, you have this, you instantiate it, and you get this empty data structure. You put some stuff in it, and while it looks like this drawing is misleading, it's assuming that the order is maintained. Technically, the way this works, it can actually throw these anywhere in the data structure, but it has a way to retrieve them really quickly. I'm not going to get into that too much. But for what you need to know is that, if you run these three lines, you'll end up with 1806 and SWAT as a key value pair, 4522 and Scream as a key value pair, 1902 and Exploding Bacon as a key value pair. And yes, that is an actual team name. They actually have a chant of oink oink boom, which is hilarious. And if you do some team numbers get 4522, it will return Scream. So I'll just take this code and run it in some robot code because I'm lazy and don't want to create a new Java project. If I do, oh, so you don't create a new correction. You don't create a new hash map of integer. What the? So yes, when you create the hash map, you don't just reuse the thing from the previous example. You actually have to. If you're changing from an array list to a hash map, you have to change it to something more like that. Because you have one data type, comma, another data type, key, value. So notice how the keys are all integers and the values are all strings. Anyway, now that I fixed my hilarious lazy copy paste error, which I guarantee will not be is not the first or last time I have made a lazy copy paste error, and it will not be the first or last time you yourself make a lazy copy paste error. Oh, and then you actually have to change the variable name. I am so sorry if anyone was confused by that declaration line. What the? Oh, and then what you run into a lot. So did you all see what happened there? That it doesn't like these quote characters. Yeah, copying and pasting code out of certain sources will just wreck the character formatting. The actual quote that you type in here and the quote that you get when you type in Google Sheets is completely different. And you run into that with code that gets developed on Linux versus Windows. There's different line endings. Copying and pasting code from unknown sources and wondering why you're having issues is always a fun game. Yeah, that should work. And then if you do system.out.print line, some team numbers get 522. And we simulate that. I hit the checkboxes and hit OK. And then go to my driver station and enable teleapp. If we go back to the debug console, this robot code is screaming at us. Ah ha ha. Ah ha. I'm sorry. I think I deserve a SWAT for that one. Yes, I know. Yes, I know I stink and I didn't close the window out before I hit build again. Yeah. So some team numbers that get return SWAT because that 1806 is the key and it gets back the value for that key. A map like this is useful if you want to store things by name or if you want to you know, store strings by a number. Like and it's going to be changing. Like you're going to get different inputs for things. Maps are not something that happen a lot in robot code, but they happen a lot in everyday code. Like, my gosh, I use maps all the time at work. But anyway, oh yeah, and this is what I was talking about. How the order is not. Okay. Oh, and then with maps, there's this function called key set or value set that will return you a list of the keys and the values in the map, but the order is not guaranteed. Like, if I wanted to do some team numbers dot get, um, I guess it's, oh yeah, it's just not get key set, it's just key set. I just print that key set out. It may be guaranteed because it's using the same algorithm every time. So it will, this may not work the way I think it will, but this ends up being the same every time because we're not changing anything about it. But say were to change every loop, I don't know. I think I'm going to cause what is known as a memory leak, or probably some kind of overflow. Good thing I've got 24 gig of RAM in this machine. Do that and come back here. What? Oh, did I not save? Oh, right, because they're duplicate entries. Oh, yeah. Hey, that's a good time to remind you all that maps prevent duplicate entries. So let me get a key that will change every loop. So if I sum team numbers dot put system dot get current time millis and do that. Um, actually hit the run code on this. Oh, system dot current time. I'm just gonna cast that too and to this is what's known as a cast. You're in a situation where you need to use that. Ask me about it first, because there are some implications. It's very easy to lose data that you thought you had by doing that. Oh, now if this doesn't immediately crash, pause. Actually, I can just hit disable. I scroll back up a ways. Actually, I'm going to restart. I'm going to enable it for only like a little bit. like yeah, as we add more things, like the order is not guaranteed to be in the order that you put things in. Like it's putting things in, and like you start there, and then that ends up in the second place, stays in the second place until something else kicks it back. Like the order is all over the place. Yeah, that is a map. Then we're going to talk about enums. Enums stand for enumerated value. The idea is that you take integer values and assign names for them. Good for keeping track of the state of something. So, other than what you just saw on screen, um, actually, you guys probably don't know. So, like, this was before enums were really a thing in programming, but if you were to write the original Super Mario game today, the Mario power up states would be handled by an enum. You know, where you assign small Mario a value of 0, Super Mario a value of 1, and Fire Mario a value of 2. Now, why would that be handy? Well, you can say you could, instead of having to save like a string for the current state, you can save the current state of Mario in just like a number, which is very easy for the computer to handle. And there's a few other reasons why you'd use an enum for that. But back then, like this is correct. If you like look at the like memory of a running copy of Super Mario Brothers, the power up state is represented this way. But they didn't have enums like we have in Java. They had to like manually handle all that. So, it's written in assembly. Your small Mario, one is large Mario, two is Fire Mario. This is great, but enums in Java, like if you're assigning a value to an enum, you can like make sure it's valid or, you know, like simplified. You can make sure that you're setting things right. Um, Back then they didn't have all that, and so you could have glitches like this, where due to certain circumstances, uh, like Mario has taken damage, but his power up state didn't decrement, right? So now you get a power up from fire state. It somehow didn't tie everything to that number, and so this now puts him back. The power up put him back to small Mario, but his power up state is some like random number that I don't know. And now he is small fire Mario because the way the flags get checked, it incremented to the right number where this was even possible. So, you know, think of our robot where it has states for certain subsystems in the code. Like the flywheel, which has like a firing state, a ramp up state, like idle state. You don't want our flywheel to end up in some weird glitch state where it thinks it's spinning up but it isn't, or like it thinks it's at the on target but it isn't. So you want to use an enum, which helps handle all that. So, defining an enum in Java looks like that. You public enum, name of your enum, because your enum is like defining a class. It's just kind of a templated thing where you just have to put in the values that you want most of the time. Nope, this isn't an instance of an enum. This is just like the definition for how your enum should work. Then using it is, you make your instance, define it public, Mario power up state equals, that's, assignment, remember. Mario power up that K no power up. Usually when you're defining it, you want to give it a sane default. Small Mario is probably the default because like after every time you die or when you start the game up from a cold boot, that's where you start at. Set up a new value, you use assignments, checking the value. Oh yeah, double equals in Java is equality. That's you're checking if this is equal to that. Or you could use a switch case, which is what we do a lot in the code. So since we're actually using this stuff in code, let me do some copy paste. A lot of time, if like the enum is being used in a class, we actually put it inside the class, or at least in the same file as the class. So in this case, it's just being used in robot. Expected Java. Public should not be capitalized. State. All right. I probably should have remembered that. So you can just put that here in the class, and now it doesn't need to be in its own file. Grab the instantiation of it. That means that we have this, which is tracking the Mario power-up state. And let me call my own bluff here. That is not what I want. Oh wait, it would just be power-up state. So internally, that enum is just like an integer. But because it's an enum, it doesn't let me do things like just assign it to some random number value or operate it on like it's a number. Which is, why, the game from 1985 that doesn't have this macro that enum is for doing that, you know, it doesn't have protections which allows small fire Mario to happen. So if you Mario Kart dot just to test the assignment, what I'm going to do is I'm going to print line state. So I'm going to print out the power up state. Oh yeah, so if you call system out that print line, you know how everything implements object? This automatically calls the .to string method of this of power up state. So that's why that works. So let's just simulate, you get a power up and then print out the new value. Actually, I can just copy that. And we're going to notice a couple things here. I'm going to have to be very quick about enabling and disabling this. Also, I can't see chat. That's probably a problem. Okay, no one's had any questions. So enable, disable. Quick. So it started up as no power up, but even though we kept reassigning it, it printed out a case Super Mario because this was saved in the robot class and was persistent across calls of the teleop periodic. So the first time that this printed, it was, K no power up because that's what it initialized to. At any point after any one of these assignments ran, which would be the second time this got called, or when this got called, when this ran, it would be Super Mario. I could even do this. So this is a double lesson about class variables retaining their state across calls of functions, and also just enums. This simulate code on desktop. It might long enough after closing it to simulate code on desktop. We enable no power up, Super Mario, Fire Mario. But then that first call ends up, it just, ends up being Fire Mario, Super Mario, Fire Mario, because the Fire Mario gets carried over between times where this got called. So, anyway, um, otherwise, I think that's all I have for tonight. Unless, anyone wants to talk about the website. But yeah, I think that's it. So, I guess anyone have questions? Uh, Roman is going to be doing the website Friday. I mean, well, I mean, so I guess I'll have questions for you all since you guys don't have questions for me. Uh, is the order of a map guaranteed? Awfully quiet. Okay. No, the order of a map is not guaranteed. Hmm, let's see. Well, I guess if no one has questions, we'll call it here for tonight. Again, remember everyone, with your day off this week, not having any meeting on what would normally be the Saturday meeting, you are expected to be reading the FRC manual in preparation for Cowtown. And if you have any questions about the manual or have confusion about any of the rules in there, feel free to ping me on Slack or group me or wherever to try to get an answer, because I, for the most part, know the manual. Like, I don't know if I would pass a test on it at this very moment, but I know like a good portion of it. Anyway, good luck with that and anything else that's going on this week. Hack Halloween, and that will be the meeting for this week. Thanks.